So hello everybody from my side too. My name is Max Klosen. A little bit of background information to myself. I was born and raised in Germany in a family of forester and carpenters. So I have some practical experience in carpentry in Germany, timber framing, and I also traveled around as a journeyman in Germany after my apprenticeship. Then shortly after that, the beams got too heavy for me, and I decided to study timber engineering in Rosenheim, which is a famous timber engineering school in the Bavarian area. After that, I came to Canada, since it was always my lifetime dream to be here in Canada, in particular in British Columbia. And then I studied timber engineering at the University of BC with a master's degree in engineering. Today we will talk a little bit about or introduce modern timber connection technologies. This is our specialty. We have done quite a bit of research on it and built our expertise on it, and we would like to show you what you can get and what is available in North America. Briefly, we will give you a quick introduction. We will talk about structural wood screws, pre-engineered connection systems, composite systems, lifting systems, and of course we will have a quick conclusion at the very end. So first of all, we would like to give a little note that technology has advanced, not only in the phone industry, just like we see here in the first picture. The first phones had, or it was not easy to use them. We had to generate electricity first, we had the dial pad, and it was not very convenient. Then later, when I was a little kid, I still remember that we had these phones with the dial pad and the big handle that you had to pick up and dial. And today, we all use these smartphones with big displays, and we can actually view PDF files and structural drawings, just like we see here on our phones. And not only technology has advanced in phone technology or in cell phones and landlines, but also in timber connections. So sometimes if we look at some of the structures and designs, we feel like there is no advancement in it, but there is certainly advancement in timber connection technologies. So yes, we did advance in it. In particular, we advanced in screw and our glue technologies that we currently have on the market. In regards to structural wood screws, we can basically distinguish the screws into fasteners, where they are extremely versatile for securing, stacking timber pieces, pulling timber pieces together, and connecting wood to wood, steel to wood, and wood to concrete. If we look into more engineered applications, we can use structural wood screws as a reinforcement, which we will address later, and composite, which we will also talk about later. So we can use these fasteners to reinforce our timber elements and create composite actions between different materials. From a sustainability point of view and LEED certification and so on, it became very, very important that the manufacturing process of structural wood screws is ISO 5001 certified. This means that most of the manufacturers have the ISO certification. This means they use sustainable energy resources and have energy management systems into place to manage their energy use and be as efficient as possible and as green as possible. For structural wood screws, we basically have two different major groups. On the left-hand side, we see the partially threaded screws, and on the right-hand side, the more engineered screws, the fully threaded screws. Diameters for these fasteners range from 1/4 inch to 9/16 and come in length from 2 inches all the way up to 59 inches. In terms of code approvals, which is in particular important for engineers in order to have design procedures and design values in place, of course, most of these fasteners are manufactured and developed in Europe. So they are all approved with an ETA, a European technical approval in Europe. Similar things apply to Australia, and in North America we are slowly getting into the approvals. There's one company on the market or one particular brand that has an approval, a CCMC approval in Canada, and also aims to have an ICC approval for the entire product range, including fully threaded wood screws. So what is so special about structural wood screws? First of all, the structural wood screws have an engineered tip. That means they have a self-tapping tip or a self-drilling tip. There's differences between tapping and drilling, which we will not address today, but just to make you aware of it, there are differences in it. The self-tapping tip basically reduces the drive-in torque and pre-drills a hole with the proper diameter, which avoids a reduction in pull-out resistance, which we would get if we have an oversized pre-drill hole. The major brands all come in washer heads, hex head, cylindrical heads, and countersunk heads. Each of those head shapes has its particular application in timber construction. The biggest element in terms of differences is probably the shaft. So what we can see in the right-hand picture here is that the screw displayed in the center has a very thick shaft and small thread wings. The screws to the left and right have exactly the opposite. They have a smaller core diameter and larger thread wings. So with larger thread wings, we can create more bite into the wood and create higher pull-out capacities. Also, we reduce the so-called wedge effect, the splitting of the wood. This means we can fit more fasteners into the same timber cross-section and potentially even reduce the cross-section and make it a more efficient timber connection system. If we look at the capacities or strengths of these screws and compare it to a standard lag screw, which we probably have all used in our design. So let's take a look at the 1/2-inch lag screw from the Canadian Engineering Design and Wood Standard CSA OD6. We will see a bending yield strength of 310 MPa. If we look into the CCMC approval for the 1/2-inch code-approved screw in Canada, we will see a bending yield strength of 1147 MPa. This will give us big capacity differences if the bending yield strength of the fastener is in control of the connection capacity. So even with smaller core diameters and smaller shank diameters, we can actually get larger capacities if the bending yield strength controls our connection. Also, we need to pay attention to spacings and edge distances, as the spacings and edge distances for structural wood screws are different to the ones of lag bolts or DIN screws or regular wood screws. Screws loaded laterally will basically follow certain spacing and edge distance requirements, and screws loaded in tension, where the force component is parallel to the screw axis, can use smaller spacings because there are less splitting forces in our connection systems. If we talk about or think about shear connection systems, we can basically use the structural wood screws, drive them in without pre-drilling into our system, and create a regular shear connection where the force component is perpendicular to the screw axis. We can do the same or utilize the same concepts for steel to wood connections, where we have a steel side plate and the timber main member and connect the steel to the wood with our structural wood screws. If we now need to get into higher connection capacities, we want to use the pull-out capacity of the fastener, because the pull-out resistance or withdrawal resistance of a screw is much, much higher than its bending or shear capacity in timber. So what happens if we basically turn the screw by 45 degrees and put it into a steel plate or a timber connection? Well, we will get a tension connection, utilize the withdrawal resistance of the fastener, and get higher connection capacities and stiffnesses. As an example, we would like to show you one of the biggest projects here in Europe, where they have a timber truss with a large tension bottom cord splice joint. The splices were needed for a transportation purpose, and as you can see, we have a very big steel plate with a lot of screws, 3/8 by 39-inch long, fully threaded wood screws, actually driven in on 45-degree angles to connect the tension bottom cord splice joint in this truss. So a lot of these fasteners in a connection can make it a very, very strong connection. Thinking about the most recent topic of CLT systems, cross-laminated timber has become a major topic in North America. And since the major structural connector in CLT are wood screws, we really need to think about, okay, how do we design this and how do we connect this? Shortly, there will be a design guide available following values and design procedures outlined in Canadian code approvals. So there will be a design guide for you available for free within the next 4 weeks. For today, we want to look at some testing that we have conducted in order to come up or develop the design guide on CLT butt joints. Test data is available for the surface blind joints in fall 2014 and also for half-lap joints. We will do some research and verify our assumptions in our design guide. So if we look at existing data for the butt joints, we basically have two connection configurations. The first one will be the screw driven in on a 45-degree angle to the panel plane and has a plane shear action of the system. we will get around 6,700 pounds at 2 inches of displacement for this connection type. So what happens if we put the screw into a double inclined angle now and utilize its tension capacity? For this connection type, we will get 10,000 pounds capacity and only 3/4 inch of displacement. So this basically indicates by turning the screw off in a 45-degree angle, utilizing its tension capacity, we get much, much higher capacities and less displacement. So what we basically do here is we buy capacity and pay for this with ductility. We can see the curves are not as ductile, or the entire connection performance is not as ductile as in a plain shear connection. So this is something we have to watch out for if we design with structural wood screws in tension. This shows us the general difference. On the bottom, we see the dowel action of fasteners, which is very flat but very ductile, and the inclined line is the performance of a fastener in withdrawal or tension. In terms of money rules the world, so we always need to consider cost efficiencies, in particular in larger structures. Here we look at a regular 5,000 pound shear connection. On the left-hand side, we designed this connection with regular 8 lag screws, 1/2 inch by 10 inch. Cost will be around $18, and we need around 15 minutes to assemble this connection, including the pre-drilling. If we were to use structural wood screws on this, we can use a 1/2 inch by 12 inch fully threaded screw with 1 assembly screw. The screw cost would be around $16, and the time required to assemble it is around the 6-minute mark. So we can utilize this connection system to make our fasteners more efficient in bigger structures. Of course, if we only have 2 connections in a residential home, the time saving doesn't really matter. But if we have 1,000 connections in a commercial timber structure, a time saving of 6 minutes can reduce our cost significantly. Getting into more engineered applications, we talk about reinforcing timber. So wood has inherent weaknesses in perpendicular to grain crushing, perpendicular to grain tension or splitting, and parallel to grain shear failure. Concrete has similar weaknesses in tension. So what we do in concrete is we put a whole lot of rebar in it in order to reinforce its weakness in tension. What do we typically do in wood? Well, in wood we have no real reinforcement technologies embedded in the code, so we typically try to avoid stresses in weak directions or use concrete and steel instead. So what we are thinking is, what happens if we put a piece of steel, speaking of a structural wood screw, that is embedded into our timber element, like shown in the bottom picture? Would that not be the general same idea for reinforcing timber? And yes, projects locally here in Vancouver show that this is a valid technology. So engineers have used this concept of basically bridging stress concentrations at the origin of cracks. So if we have deep checks or cracks in our timber elements, we get stress concentrations at the origin of the cracks, and we would basically have to reduce our cross-section to a smaller one. So what happens if we drive a structural wood screw through those checks and basically build a bridge for the stressor to travel across the crack? This would allow us to re-establish the old cross-section and have a very efficient timber reinforcement. So this project here was in downtown Vancouver just about 2 years ago, I believe. It's a 4-story post and beam timber structure, heritage protected, and the beams needed reinforcements. So we used 3/8 by 31 inch fully threaded wood screws driven in on 45-degree angles to reinforce the deep checks and cracks in the timber elements and post elements. The outcomes and findings for this were cost savings. It's a fast and clean and quiet construction technology because all you need is a drill, the screws, extension cord, and maybe a ladder to reach to the beams that are high up on the ceiling. Also, we were able to preserve the beautiful old growth timbers in the structure and kept the heritage status of the structure without changing the visual appearance. Also very important to mention is that for this structure, the building was kept fully occupied. There's a big software company located in this building with lots of software, lots of computers, and they really needed to keep their employees working for this construction period. So what we did, we came in at 6 p.m. at night and worked till 6 a.m. in the morning and just drove in wood screws all night long. Another efficient reinforcement technology, of course, is to reinforce regular notches in order to avoid cross-section reductions, or reinforce perpendicular to grain if we hang something onto a beam and encounter perpendicular to grain stresses. Design methods for this are available. If you have not seen these design methods, most of the Canadian or US distributors will have technical support available for you, and they are pretty happy to forward you the design procedure and help you with the design of the system. Compression reinforcement is also a new concept where fully threaded wood screws can be used. How this basically works is you drive the wood screw into the timber element. The wood screw acts as a stiff element, attracts the loads, and transfers the loads along its axis to the tip. The loads are released back into the timber, and because of the stress propagation in timber, we can now utilize the value shown here with LEF2 as our bearing area. In regard to stiffness and flexure reinforcement, this is also a question that frequently comes our way. There are a few different options on how to do this. You can, if you want to use timber elements, you can, for instance, screw a 5/16 steel plate or a 1/4 inch steel plate, depending on the values you need, onto the bottom of the beam, and use the steel plate in the tension zone on the bottom with screws in tension to increase the flexure stiffness and the capacity of the beam. So with a 5/16 steel plate, we can go up to 80% in ultimate load increase and a stiffness increase of around 50% for our timber elements. So if we have an existing beam that is over deflecting or overloaded, this is certainly a very efficient technology to reinforce timber elements. The same applies if we basically bolt on another timber element onto an existing timber beam. This is from a local project here again in Vancouver, a school building. So the beams were deflecting too much and needed reinforcements. In some areas, there were timber elements screwed onto the bottom of the beam into the tension zone, and in some areas we reinforced the upper element of the beam in the compression zone to increase the cross section. Fully threaded screws were again used to transfer or establish the connection between the new element and the old element without removing the existing beams. This is it so far to structural wood screws. Now we will go into the pre-engineered connection systems. For pre-engineered connection systems, we have one particular problem, that there's a large variety on the market and they are not necessarily code approved. So in order to use these systems according to codes, we can go in Canada into the CSA 086 and utilize clause 3.3.2, and in the NDS we can use clause 1.1.14. These clauses basically tell us that North American timber design standards permit the use of new connection systems if reliable test data or analysis based on recognized theory is provided. So how we would approach this with European connection systems, for instance, is most of these systems are ETA approved. Again, this is a European technical approval similar to a CCMC or ICC approval in the US, where you can find the approval numbers from your technical support or your hardware supplier, and these approvals show you design methods, and you probably also get easily access to test data where you can verify your design based on real test data. As we see, most of these systems again use a lot of structural wood screws, as their capacity is often controlled by structural wood screws. So structural wood screws also play a major role in pre-engineered connection systems. All of the manufacturers have small systems for pre-manufactured walls, stairs, and rather furniture type connectors, or for CLT panels. So the small systems are for the pre-manufactured elements or stair elements. Larger systems like those ones have two different basic systems. One system to the left is where screws are driven in straight into the grain, end grain or side grain. End grain always receives longer screws, side grain receives shorter screws, and the screw is basically used in its plane shear action. Capacities range up to somewhere around 10,000 pounds, maybe even up to 100 kilonewton, depending on where you use it and which timber species you use it at. On the right-hand side, we see a different approach with aluminum plates. There are several manufacturers on the market with dovetail shapes, without dovetail shapes, V shapes, notches, and whatnot. So you will have to find the system that you like the best and you think is the best for site assembly. The aluminum systems mostly use screws on an inclined angle of 45 degrees to again utilize the fastener's pull-out capacities. A big advantage of the pre-engineered systems is that we can connect wood to wood elements, we can connect wood to steel elements, and we can connect wood to concrete elements using the same system. So the assembly procedure and quality control procedure will always be the same, and we can standardize our process and make it more efficient. Here we have a short example of how these systems are used. On the top we see a CLT wall with pre-installed systems, and the beams already carry the connector. So what we do on site, we just put them together, and we are actually able to test fit the system in the shop as well, and can make sure that our tolerances are all okay for site assembly. If we were to use it in a steel connection, we would basically, a steel to wood connection, we would basically go in and use structural wood screws in the timber element and a 3/8 or 5/16 bolt or 1/2 inch bolt, depending on our load requirements, into the steel post. And then we can again use the same procedure and connect our elements into place. Assembly procedure for all brands and all connectors works in the same way. We see the timber element, we lay it out, we place our connection aluminum plates or steel plates on it, we drive in all the wood screws into the main girder and the joist member, and once they are all driven in, we can assemble the system together and create our shear connection. As we can see here, most of these systems can be applied with all 3 sides concealed or even 4 sides concealed, depending on the intent you have. Also, of course, these systems can be visible, but most of the people, of course, like to have the fasteners fully concealed. In terms of tolerance requirements, we get a lot of questions and concerns from people that are concerned about how do we do this on site, how do the tolerances work. So for this particular system here, we have about an 1/8 of an inch tolerance for the beam assembly. This means if you have one connector on each side, which gives you a 1/16 of an inch tolerance on each side of the beam. The tolerance requirements should be okay and are practical, considering the short way of engagement that you need to slide the connector into place. Fire. So if we want to use timber in commercial timber construction, which certainly is one of the goals that many of the engineers and architects have, we need to think about fire protection and how we do this in our timber systems. So for the pre-engineered connection systems, it's actually fairly simple. We can use the charring rate of wood to calculate our fire ratings, as long as we conceal the connector from at least 3 sides or 4 sides. And if we can make sure that the connectors are tight assembled, that means we cannot allow for more than a 1 millimeter gap between the main member and the side member. Here we just see a project, one of the biggest connections done so far with this pre-engineered system. We have around 50,000 pounds resistance, and we can see above the red arrow here on how big these systems get. So a big load will just always require a big connector. For the last part on systems, we go into the composite actions of wood to concrete systems. We will just give you a quick introduction here, and if there is interest on one of these topics for later webinar in this later summer this year, we can address design procedures of these systems and probably also give you an insight on recent testing that is going on here in British Columbia. If we talk about wood to concrete composite systems, we always talk about implementing water into our building because the concrete will be pumped in. So if we have a large amount of wood in our timber structure, we might run into concerns that the timber soaks up a lot of water. We have to do on-site form work, and we may need to be concerned with temperatures in winter, in particular here in Canada, where it gets very cold in the winter time and concrete pouring can become a problem. So there are several systems on the market that address these issues in different ways. One is for sure the epoxied in metal mesh, which can create wood to wood connections, steel to wood connections, or wood to concrete connections, and then the pre-manufactured FT system, which works with structural wood screws and generating a pre-manufactured element. So what we see here, we basically have the shear connector embedded into our concrete element off-site. So the concrete elements are pre-manufactured in the concrete plant. They are cured in the concrete plant. While this is happening, we erase our first structure of the story of the timber structure. Once this is done, we drop all the elements in place. We pop in the little lid with the structural wood screw and drive the structural wood screw through the pipe down into the wood. And once the wood screws are all driven in, we created full composite action of our system without having to set up any formwork on site, without being dependent on temperatures on site. So this can certainly increase construction speeds and keep construction going during the winter time if need be. The HBV HSK system with the epoxied-in metal mesh is also a European system, very well researched and also available in North America for use. The biggest advantage of the system is its outstanding performance in terms of stiffness and ductility. It is basically a mild steel plate that is epoxied into our timber element and concrete is poured over it. So the mild steel gives us a very, very ductile performance while maintaining a very high initial stiffness. Both of these systems basically intend pre-manufacturing of wood to concrete composite systems. As we can see here, the concrete is poured in the plant, independent of the temperature outside. It is cured and then lifted into place in a large element, probably screwed down for securing it, and then we have assembled our bridge or floor panel. Talking about pre-manufactured elements and lifting of these elements, we often run into problems. Okay, how do we lift these panels now? For CLT lifting, for instance, there's a few systems on the market that are used already. One system is the inserts. Inserts are pre-drilled, inserted into the CLT element, and a lifting anchor, a threaded wire lifting loop, we call it, is threaded into the insert and lifted up. So this is a very simple and easy to use system. Loads go up, or lifting capacities with 4 lifting points and spreader bars are somewhere around 5,000 to 7,000 pounds, depending on the lifting conditions. Another system we are currently developing is a steel plate system with, again, structural wood screws to lift wall panels from the flatbed truck onto the construction site in one lift. And we will also address lifting of or steel plates for lifting of wall panels, CLT or LVL panels, maybe even nail-arm panels, which appear more and more in the market. A design guide and lifting procedure for this will be available in the next 6 weeks, and then we have a safe lifting procedure developed for CLT or pre-manufactured element handling. A lighter duty lifting device would be the transport anchor. Again, this system works with a structural wood screw, 1/2 inch diameter, 6 1/4 inches long with a full thread. The full thread gives us a lot of pull-out capacity, and the system can lift up to 1,000 pounds, 1,500 pounds actually per lifting point, depending on the timber species and the lifting conditions we are in at. We can use it for lifting with helicopters here, as we see on the lower left picture, or we can lift it with a regular crane. It always depends on where you use it and how you want to use the system. But it is certainly a very cost-effective and efficient way of lifting timber elements. In regards to accessories for steel plate to wood connections, there are several systems available from each manufacturer. On the top, we see a so-called 90-degree cup washer. These cup washers basically eliminate the countersunk pre-drilled hole in the steel plate and reduce manufacturing cost of the steel plates, as it is fairly expensive to remount the hole with the proper diameter to receive the screw head properly. So these washers basically substitute the reaming out of the hole and reduce steel plate manufacturing. In the lower picture, we see a new technology with 45-degree wedge washers. So this system will give you the advantage of using the pull-out capacity of the screw if you require high capacities and stiffnesses. This system is available with 5/16 washers for 5/16 screws, 3/8 and 1/2 inch fasteners here in Canada and the United States. Again, this 45-degree washer system is intended to reduce the steel plate manufacturing cost. Most of the cost savings come from the reduced thickness of the steel plate and also the cost that occurs with the manufacturing of the hole. So the 45-degree washers only need a punched hole or a milled hole rather than a hole milled by a 5-axis CNC machine. So again, we only intend to reduce steel manufacturing costs here and get the fastener in tension rather than in shear. Here we have an example from a local company that used these washers recently in a bigger project, where we can see the washers being used in a tension connection node in a steel plate and wood. So what we can say in conclusion is that there's big advancements in screw and glue technology. Glue technology mainly for the wood to concrete composite, HSK and HBV systems. Screw technology for all the other systems that we showed you, and without screws and glue we would basically be screwed because we would not be able to build all these beautiful and big challenging timber structures. In summary, we can basically say that back in the days we were riding the carriage because we didn't have anything else and time didn't really matter. However, today we are all in a rush and time matters. So we would rather prefer to drive a Ferrari against the carriage. So a good example to compare this is that the old-fashioned lag screws, where you have to pre-drill a long hole, the quality is not controlled in a very good manner, probably rather compared to the old carriage. And the modern timber connection systems can certainly help us to increase construction speed and make timber connections and timber construction more efficient and more competitive with steel and concrete if we need be. Here are the references that we used for this presentation, and now I would like to thank you for attending this webinar. I hope it was informative and gave you a brief overview of what is available in Canada and the United States in regards to modern timber connection technologies, and I hope we can stay connected for the future. I will hand it back over to Matt now. Matt will do the final words on it. Our contact information is displayed here, and if you have questions now, we will of course be available to answer some of them. Matt, could you take over?
Yes, perfect. Thank you, Max. So we will now go into the Q&A session. So we're going to go in Q&A mode. So feel free to either just use your phone or your computer to ask your questions, or the chat. They both work. If you have to leave now, please, again, just a quick reminder that if you could take the survey, that would be really great. And now I'll just
all attendees are muted and may unmute themselves by pressing *6.
So you can ask your question now. Thank you. So we have a few questions on the chat, Max.
Yes, see that.
Okay, so for the slides, we'll look into this and we'll get back to you in our follow-up email, see if we can get the slides to you. I saw questions about resources as well. So in the follow-up email, we will also have the link to the video so you can replay the video, but we'll also include spec sheets, fact sheets, guides. So you will have that. If you need more though, please, by all means, just reply to that email and let us know what you're looking for, and we'll find the right information for you. As we said at the beginning, we can certainly schedule a phone meeting with Max as well to go, in more details. Today's presentation was really like an overview, so we didn't go into too much depth yet, but in future webinars we will go into more details.
Okay, so I just quickly want to address some of these questions that are popping up here in the chat. So 45-degree slope washers, yes, they are available for the half-inch screw. We do carry some of these in stock here in Vancouver. We are just looking into the first projects where these are used. Also, there may be two US projects that use the half-inch washers in big timber structures. Jing from Vancouver is asking about the availability of 90-degree washers. So 90-degree washers are available for the 6mm screws, the 8mm screws, and the 10mm screws. We did already have some requests for the half-inch screws, and we will certainly work on that and have this available hopefully by the end of the year too. In regards to sourcing some of the products for different brands, there are distributors across North America, in particular East Coast of Canada, West Coast of the United States. Your local technical support will be happy to, for sure, or your local salespeople to point you in the right direction. For our particular products, we ship throughout the entire West Coast from our Vancouver warehouse within 4 to 5 business days usually. So if you order from us in the morning before 11 a.m., we will ship it out the same day. To Seattle, to address this particular question here, it would usually take 2 business days to get there. Yes, we will make the slides available in a PDF format. I think it is probably available already. I would have to confirm this with Matt, but yes, the slides are going to be available for downloads. Our design guide will be published probably with a newsletter that you may want to sign up for, or maybe you are signed up for it already as a follow-up for this webinar. So as soon as we have it ready and shop drawings are reviewed for all the design guides, we basically publish that with the newsletter. Here's one interesting question from Brian Doyle. Thank you, Brian, for asking this question. I actually forgot to address this in the webinar here. A very important question is, so if we use fully threaded wood screws in wet wood or in green wood, this is certainly not something we can do. So the fully threaded wood screws are basically a piece of rebar that is embedded in the wood, and if the wood tries to shrink or swell, we introduce restrained shrinkage stresses or swelling stresses that can actually tear the fastener apart in tension. So the wood is very, very strong when it shrinks or swells and develops enormous internal forces that can damage the fastener or even produce stress release checks or cracks in other areas of the timber element. So fully threaded wood screws can only be used up to a moisture content, say between 18 and lower. So we need to have kiln dried wood to use fully threaded wood screws efficiently without encountering any problems. Partially threaded wood screws, however, can be used just like lag bolts as well in any type of wood, also in green wood, as long as we make sure that in a 2-member connection the threads are only embedded in one of the members, so that the wood can basically slide freely along the shank, up and down, or move.
So I see many questions about replay and slides. So just to make sure this is clear, so yes, this will be available for replay. We will send you an email with the link, and in that email you will find the slides for this presentation as well. So you will have access to everything.
One question here from Charles, if he's still online. Any issues with alternating efforts and inclined screws? So far, we have not seen a lot of complaints with inclined screw arrangements. You have to be particularly cautious or careful if you use inclined screws in steel plates, because once the screw head engages with the steel plate, for instance, a sudden torque increase happens. So for this, we always suggest to use a torque clutch or a torque controlled drill, which we do actually have available too, for rent or sale, of course. However, if you have a well-experienced construction workers, this issue is not a real concern. Inserting wood screws on an inclined angle with, say, 45 degrees or 30 degrees or similar into a wood-to-wood connection, we typically suggest to pre-drill a short 2-inch guide hole to basically guide the screw in at the proper angle, and then it's just the same procedure as driving in a regular wood screw. In overhead applications, if you have existing beams in a roof structure, for instance, it is, of course, more work to drive in the screws because you are working overhead and you have to basically hold the drill overhead and stabilize it to drive the wood screw in. So for the southeast, Graham Montgomery is asking a question here. Shipping will be right now for the fully threaded wood screws from Canada here. We are working with a partner there, and I hope we can get a warehouse set up in the southeast of the United States this year. Another question here. Yes, you can watch the webinar again. I believe you will be sent a link where we can listen to the recording again. One interesting question here too, if structural wood screws could potentially hold down twisting timber elements, Douglas fir or oak. So as I mentioned already, if timber wants to twist or wants to shrink or swell, it is going to do it no matter what you do. Unless you really tie it down with big steel elements, you will not be able to prevent the timber from twisting, in particular not Douglas fir or white oak elements. Yes, there's one question here. Are Canadian design values available? Yes, they are available. We have, for particular products, we have Canadian code approvals, and the Canadian code approvals, of course, give you design values. For instance, for pull-out or the withdrawal resistance per 20 millimeter of penetration into the timber element on 90-degree angles, 45-degree angles, and very steep or flat 30-degree angles. With an inclination, you will see a decrease in pull-out resistance, as it is typically observed. Also, the design information will give you the head pull-in capacity, which is basically if you try to pull the head into the timber element for all the typical head shapes, which is washer head, hex head, cylindrical head, countersunk head. In regards to fully threaded screw head pull-in, there are no head pull-in values for this, as the head pull-in capacity of a fully threaded wood screw is controlled by the threads and not by the head. So for this one, you basically calculate the pull-out resistance or pull-in resistance of the threads. Also, the design guidance for Canada gives you shear design values for a 1/4 inch, 5/16, 3/8, and 1/2 inch fasteners in any sort of wood-to-wood or steel-to-wood connection. basically we use different side member thicknesses from 2x4 to 4x4, 6x6, 8x8, and so on. Douglas fir glulam, SPF glulam, and then all the lumber species that we have tested. Also, it gives you values for one engineered wood product, which is PSL. Yes, there's one question here about a screw that can anchor timber elements into concrete. So yes, there are screws available like this from several brands. You basically have to pre-drill a hole into your timber element. You need to pre-drill a hole into the concrete and then just drive the wood screw through the timber element down into the concrete. One question here from Simon from St. George. So yes, we have done all our testing, of course, in Canadian timber species in a certified Canadian lab here in BC. So the lab we tested in is code approved, and the entire testing procedure was certified by the code approval agencies. We have tested Canadian Douglas fir glulam, Canadian SPF glulam, Western red cedar, I believe hemlock, and Canadian PSL to give you the entire density range from basically 0.5 all the way down to whatever Western red cedar gives you, which is I believe 0.35 in the mean average dry density. Okay, I believe we have addressed most of the questions.
Any more questions? Anything we missed maybe? Because it's pretty quick on chat. Thank you all for your great words. We're glad you enjoyed the presentation. Okay, so I think if we don't have any more questions, I think we'll wrap it up. So once again, we will send you an email today with the references, the technical information, and a link to the video for replay purposes. So in the meantime, if you have any questions, you can visit our website at myticon.com. So that's myticon.com. And you will get our contact information in the follow-up email you will receive today. So again, thank you very much, Max, for the presentation, and thank you everybody for attending today. Okay, have a good weekend.